Hiya, how you all doing? So in this video I'm going to look at problems where you need to find mu and sigma. You need to find mu and the standard deviation. So here's a very typical example then. So you're told that x is normally distributed with mean mu, we've got to work out what it is, and we've got the variance as 3 squared. Okay. We're told this, we need to be given more information, obviously, to work out mu's. We're told this, the probability x being greater than 20 is 0.20. We've got to find what mu actually is. So in my diagram here, notice I've just gotten rid of the numbers now, I kind of don't really need those. In my diagram here, what we're looking for is the probability that x is greater than 20 is 0.20. We need to find a corresponding value of z such that the probability z is greater than that number is equal to 0.20. Now, up to there is 0.5, so I know that if it's greater than 0.20, I know that it's going to be somewhere there, okay? So this bit is 0.20. We're going to work out what the value of z, small z, is such that that will happen, okay? Or let me just put it another way. This here, we can rewrite that as the probability that z, capital Z now, is greater than, and then we use this coding formula here, because for any x value, we subtract mu and divide by sigma to work out z. So probability z is greater than 20 minus mu all over standard deviation, which is 3, is equal to 0.20. Okay? It's important when you're using the tables that you just reword this statement in terms of z, and there it is. Okay? Now, when we use the tables, because it's 0.20, we can actually use the percentage points table, so it's set up nicely for that. Remember, the percentage points table helps us to work out corresponding values when it's a greater than situation. That was the probability to the right hand side of this bit here. So look at the points table, which I've done earlier. It is 0.8416, okay? 0.8416. So that value there, you see, that comes out as 0.8416. So that means that this here must be 0.8416. Okay? So 20 minus mu over 3 equals 0.8416. So I'm hoping you can see how that has worked out for us. Now we need to work out the value of mu is. So 0.8416, I'm going to multiply by 3. Okay? And then I'm going to subtract 20. And of course, that gives me negative mu. So I'm just going to write down the negative of what my calculator tells me. Okay, so that means mu must be 17.4752. So I'm going to put 17.5 to 3 significant figures. Okay, and then that's the first example done. Okay, so this next example, we're told that x is normally distributed, mean 50, but then we're not told the standard deviation of variance, so it's sigma squared. And we're told that probability of x is less than 46 equals 0.2119. We've got to find sigma, of course. Okay. Well, first of all, let's just rewrite this, shall we? So we know that we can use our coding effectively to let's use blue to be consistent with my previous bits on this video. So we can use the coding to say that we've got z is less than, then it's 46 subtract mu, which is 50, over sigma is equal to 0.2119. So first of all, that's how we reworked it in terms of z. Then we use the tables to try and work out what this value must be. Okay, the points table is not going to help us because 2.119 is a bit awkward. Okay, you can use it if you want as an estimate, but I wouldn't. 0.2119, it's not really accurate to use 0.2, so I'd use the other table and try and see what we can do with that. Now looking at the other table, a reminder that this actually helps us when you've got values between 0.5 and 1, which of course this isn't, so what we can do instead is we can look up the difference between that and 1. So we can look at 0.7881, okay? We're going to look up 0.7881. Maybe just find the table and do that for me. I've done that. Very nicely, we get an exact figure with p is 0.7881, and the corresponding value for z is, let me just read it off, 0.80, okay? 0.80. So what does that mean, okay? Well, let me just write it down. We found the probability that z is less than a particular value is equal to that, 0.7881. And let me just put up here the 0.80 that we just found, okay? So what I'm saying is that all of that, okay, has got a probability of 0.7881, all right? But of course, we want the probability Z is less than this is 0.2119. What does that 0.2119 mean? Well, it's this bit here, okay? That's the 0.2119, okay? That's how we interpret this. So using the tables on that, we found up to 0.8, the probability is 0.7881, so therefore greater than 0.8, probability is this. Then using the symmetry, okay, this bit here is also 0.2119, okay? So this bit here, probability Z is less than this being 0.2119, that corresponds to that value there. And of course, that's what we're looking for, because that's what's going to help us to find sigma, okay? Now, that being the mean 0, and that being 0.80, this bit must be negative 0.80. That's an extremely important part of this, because if you don't use negative 0.80, you're going to get it all wrong. Okay, so that's negative 0.80. Now, in terms of working out what sigma is then, so I've just discovered that this bit here that I'm writing out, 46 subtract 50 over sigma, that must correspond to negative 0.80. And now just go ahead and work out what sigma is, okay? You might have noticed that on the numerator, 46 subtract 50 is negative, which of course puts into context why that's happening, okay? Negative being to the left of the mean, positive being to the right of the mean. So we've got negative 4 over sigma equals, it's time to go fraction, I think, because it's exactly 0.80 and got it as 4/5. So negative 4 over 5, okay? And I hope, obviously from that, you can see that sigma is equal to 5. Okay, I'm hoping that made sense. If not, just watch the video again, okay? Okay, there's actually a second part to this question which I'm tagging on here. So that is find the 90th percentile. So notice I've rewritten this because we know what sigma is now. So we've got x is normal distributed, mean and variance. Find the 90th percentile. How do you do that? Well, it's actually the 90th percentile, because previously we saw a question where it's in the top 5%, okay, correspondingly look at the top 10%, but here we kind of look at it as the first 90%, don't we? So the probability is going to be 0.9 of it being the first 90%. So probability of having a particular value up to what we're looking at is going to be 90%, 0.9. So we just rewrite this as the probability that x is up to a particular value, call it A, is going to be 0.9. And that's how we just rephrase the question. Obviously, using the tables, we're looking at Z, aren't we? So we're looking for the probability that Z is less than a particular value. Now, it's not going to be A, so I'm going to call it something different. I'm going to call it B. So using the tables, that's what we're looking for. Okay, probability Z is less than B is 0.9. Okay. Now, using the tables, we can work out what that value actually is. I'm going to use the first tables to do this, okay, because it comes out nicely. It comes out to be 1.2816, okay, so 1.2816, so that's our value of B. Remember, Z is less than B, so the tables gives us our exact answer. B is 1.2816, okay. So this value there, using our coding then, we must have A minus mu, which is 50, over sigma, which is 5, that must be the 1.2816, and we just got to work out A is from that. So calculator time again, 1.2816 multiplied by 5, add on 50, and it gives us 56.408. So I'm going to put that as 56.43 significant figures. Okay. Okay, so my last example. This is an important example because it's about how to find sigma and mu within the same question. Okay, so because we find sigma and mu, we don't really know what these are. Okay, but anyway, the question is probably phrased something like x is a normal distributed variable such that you've got mean, mu, sigma is the standard deviation. Okay. Anyhow, the information we're given that we're going to use is probability x is greater than 35 is equal to 0.025, and probability x is less than 15 equals 0.025. 0.1469. Now we're given two bits of information because we need to work out two unknowns, and that means this question is about simultaneous equations. Exactly, yeah, simultaneous equations. So look out for that. When you're finding two unknowns, you've got to set up two equations, two unknowns, solve them simultaneously. Okay, so we'll look at each information given to us one at a time and use the tables appropriately to find out our values of z we need to use. So the first one, look at, is probability x is greater than 35 equals 0.025, and we can go straight to the points table for that, can't we? Okay, the points table 0.025 should be in there, and because x is greater than, that means we should be able to write down straight away what the corresponding value of z is going to be. Now I'm looking for two values of z, one for this, one for this, so I'm going to call them z1 and z2. So looking at the points table, maybe you've done that already, 1.96 is what I've got, 1.96. So that's somewhere around about here, say in the diagram. I'm not going to draw this in for the moment. I'll save my diagram in case I need it in a minute. And so that's 1.96, you see. Probability z is greater than that is 0.025. Okay, so that's that. That's the first one. So the next one, let's just separate this off, is going to be this. And I've got a feeling this is going to be more challenging. Probability x is less than 15 equals 0.1469. Yeah, because it's 0.1469, that's not going to be in the points table, so we have to use the first table, the larger table. Only, of course, it goes from 0.5 upwards, doesn't it? So we're going to have to look up what's the difference between that and 1? 8.531. And of course, that will be correspondingly, probability x is greater than 15. Okay, equals 0.8531. Okay, and we can find out what that actually is. Looking it up, it's 1.05. It's notes from my board in front of me. Okay, 1.05. Did you get that? So I'm going to use my diagram now, you see. So the 1.05 is there. Of course, that's for z. Yeah. So the probability that, let's just write this down. Probability that z is greater than that figure, 1.05, equals, probability z is less than, that's how the table's working, probability z is less than 1.05 equals 0.8531. See how to think about that then, because obviously the probability z is greater than that, has got to be smaller than 0.5. That, an example of how the diagram is useful, because I was linking the diagram to this. So look, that to there is 0.8531, so above that is 0.1469. And of course, that's the probability we want, isn't it? We want 0.1469. So where to find it? Using the symmetry. It's over on this side then. So that bit in there, by symmetry, must also be 0.1469. So you've got the probability z is less than this figure, okay? And that's got to be negative 1.05, okay? Using the symmetry. So above 0, positive, below 0, negative. Same value as that, but negative. So we've got probability z is less than negative 1.05 equals the 0.1469. So what that means is that, let's just write it in down here, our other figure, z2, to use in the simultaneous equations, is going to be negative 1.05. So I've got my two values of z to use now, okay? Right, I'm just going to pause and rub my board because there's more working yet to come, okay? Okay, so board wiped, ready to go, plenty of space for the working with the simultaneous equations. So I've got my corresponding values of z1 and z2. We just now to use the formula. Remember, the formula is z is equal to x minus mu over sigma. That's our coding formula. So let's do it. So z1, 1.96, and that's equal to the corresponding value of x was 35, and then subtract mu over sigma. Okay, and let's just tidy that equation up a bit. So if I bring the sigma over to the left hand side, I've got this 1.96 sigma equals 35 minus mu. Call that equation 1, because we're expecting the second one, aren't we? So the next value of z is that, so it's negative 1.05, and that's equal to corresponding value of x is 15. So again, using the coding formula, so 15 minus mu over sigma. Let's just put the sigma over to the other side again, shall we? So negative 1.05 sigma equals 15 minus mu, and I'm going to multiply that equation by negative 1. So positive 1.05 sigma equals negative 15 plus mu, and then I'm going to call that equation 2. Okay. Maybe while I'm wiping this off, you just think about why I decided to multiply by negative 1. It was just so that it's quite simple to just add the two equations together now. Yes, I know I could have just done that one, subtract that one, that would have been fine, but I like having a situation where you can add them together. It comes at mechanics, M1, the car towing trailers question with the tensions and the accelerations. It's quite common, so I just like having a situation where you've got one negative, one positive, and they just cancel. So anyways, just add these two together. So that plus that would have been lovely if it turned out to be 3, but it doesn't, does it? Of course, it turns out to be 3.01 sigma is equal to, and then that plus that is 20, and of course the mu's cancel. So sigma then, I'm just going to use my calculator for that, is going to be 20 divided by 3.01, and that gives me, I'll tell you what, I'm going to write down the fraction as well. So rounded 6.64, say 3 significant figures, okay? But I'm going to write down the exact value. The reason for this will come apparent soon. 2,000 over 301. Okay, that's the exact value. Now I'm going to work out what mu is. I'm going to use equation 2 to do that. So using 2, we're going to have mu is, so I've still got that in my calculator display. So I'm going to times sigma by 1.05 to multiply by 1.05. Okay, and then I'm going to add on 15, and I should get 21.976. So if I'm doing 3 significant figures, I better say it's 22.0, haven't I? 22.0, 3 significant figures, and the exact answer for that was 945 over 43. Okay. Now, why am I using the exact values there? It's because I want to check my answers. With simultaneous equations, always a good idea just to substitute into the other equation to check, to verify that they also work. So the other equation being equation 1. Okay, so what I'm going to do is I'm going to do 35, subtract mu, which I had in my calculator already. No, I've messed that up. I did 35 plus, so I'm going to reset and do it again. But that's why I've written that down, you see. So 945, yes, even I can fumble my calculator. Okay, so I've got that there, and then if I divide by 1.96, I should get exactly the same answer, yes, 2,000 over 301. Okay, I've got the exact figure. So it works in both equations, therefore these must be the correct values of sigma and mu. Okay. Well, I'm hoping you enjoyed that. I'm hoping it was useful to you. Nice, it was getting some simultaneous equations into statistics. Isn't it nice when you get algebra in statistics? Okay, it just makes the whole thing even more enjoyable, in my opinion, anyway. Okay. Well, I'm wishing you a very good day.